So today we're going to continue our conversation on this ambiguous case for the law of sines. And we're going to focus more on solving for two triangles. And when we solve a triangle, it just means we're finding all of the missing sides and angles, okay? Now, if there are two possible solutions, that should say two, then we'll solve both triangles separately. Find the missing angles and missing sides for both, okay? All right. So it says solve triangle CAT if angle A equals 85 degrees, which is an acute angle, C equals 3.4, and A equals 5.1. Well, I'm going to start with a picture. So 85 degrees is almost 90 degrees, and that's angle A. Side A is going to be across from it, and it's a value of 5.1. Side C could go here or here. I like to go angle side side, so this is a 3.4. And so that would be angle C, and then that would be angle T up at the top for CAT. So when we yesterday, or in lesson 6.7, talked about an acute angle, we said look at the gate. Right, and the gate is that side that's kind of hanging from this pivot point. And if the gate is longer than the other side, we only have one triangle. Right, the gate is the longer side. That's good news for us. That means we only need to solve one triangle. So it's really just review of what we had been doing. So we know in a triangle you have three angles and three sides, and it doesn't hurt us to maybe do something like this, just to kind of organize our thoughts. Right, so I have capital CAT for my angles, and I have lowercase CAT for my side length. So it's like my answer is going to go in here. Now, they gave us three of these six pieces already. Angle A is 85 degrees, and side A is 5.1, and side C is 3.4. Just kind of keeps us organized and understanding what do we still need to find, what do we have, what are we going to use. So again, as soon as I notice I have an angle and its opposite side, we're going to use the law of sines. So I'm going to say the sine of 85 degrees over 5.1. And the only other side I have is C, which means I'm going to be finding angle C first. So I'm going to grab my calculator. I'm going to make sure it's in degrees. I am going to multiply that 3.4 to the other side. And then I'm going to take the inverse sine of both sides. So again, I decided to do all the work before I grabbed my calculator. That's my choice. Just it's easier on me. So I'm in degrees. I've got my inverse sine of my fraction. And we didn't say, let's see, let's round to, for angles, you know what, let's go to the nearest whole number for angles today. So let's call that 42 degrees. So angle C is 42 degrees. All right, well, now remember all three of these angles have to add up to 180 degrees. So I think we can go very quickly find our third angle, and we get 53 degrees. And that's an important next step because, well, if we want to find side T, we need the angle across from it. Now we're just going to use the law of sines again. I like this one right here because this was the original information they gave us. Remember how we rounded this? Which means, you know, if we use, I don't know, I just like to use the original information. So I'm going to say the sine of 85 over 5.1 equals the sine of 53 over lowercase t. And I think this is a great case for cross multiplication. So I have t times the sine of 85 equals 5.1 times the sine of 53. And then I'm going to divide both sides before I grab my calculator. by the sine of 85. So I have, in my fraction, 5.1 times the sine of 53 all over the sine of 85. Let's see, this is a side length. This side lengths they gave us are to the nearest tenth. So let's go ahead and round our value to the nearest tenth. So lowercase t is approximately 4.1, and I'll just go ahead and fill that in up here. So again, when we solve a triangle, we're finding all of the missing pieces. They gave me they gave me an angle and two sides, which means I need to find two angles and one side. All right. So let's take a look at this last one. It says solve triangle ABC if angle B is 38 degrees, side B is 45, and side A is 60. Now look at all this room I gave us. Pretty good indicator that we might have two triangles, just a thought. But let's go ahead and draw what we have. We never want to make assumptions, do we? So B is about 38 degrees, an acute angle. A is 60, and B is less than that, it's 45. So let's see, 60 is A, so that would be A, which means angle C would be at the top. So just real quick, I'm not assuming that we have two triangles, but if this is an acute angle, and if the gate is shorter than the other side, I'm going to write that down. So the gate is shorter, that means we either have 0 or two triangles. And we won't know until we start solving the triangle. So let's see, we've got angle A, angle B, angle C, side A, side B, side C. So I'm kind of just, like I did above, I'm just kind of setting up my answer here. All right, so angle B is 38, side B is 45, and side A is 60. So I'm going to come down here and I'm going to start doing the math. The sine of 38 over 45 equals the sine of A over 60. So again, if my calculator gives me an error, that means no triangle exists, the gate is too short. If our calculator gives us an answer, that means we have two triangles, and then we'll talk about what we're going to do next. All right, so let's move that 60 to the other side, and then we'll take the inverse sine of the left side. All right, so here we go. We've got the inverse sine, and in that fraction we've got 60 times the sine of 38 all over 45. Great. So, oh, yeah, great. The calculator gave us an answer. That means we have two triangles. So I'm going to write this down. We have a 55-degree angle for A, which means we have two triangles. So let's go in here and write this down. Angle A could be 55 degrees, or let's label this triangle 1, and then maybe I do another box for triangle number 2. Right, so we're going to like kind of put in the same thing. Angle A, angle B, angle C, side A, side B, side C. Now I don't want to forget that we know for sure angle B and side B and side A, right? So in both boxes that information has to stay the same. All right, so we know we have two triangles, so I'm kind of setting up both of my answers here, right? These are two different answers. All right, we found one option for angle A. That's in this triangle right here. We said this angle is 55 degrees. However, I'm going to draw my second option. So let's do it down here. So angle B is 38. Side B is 60. And instead of swinging out to the right, it could swing in to the left. It still has a length of 45. And instead of swinging out this way, it swung in this way. So maybe I didn't do it enough, but that's okay. We're looking at this triangle right here. Okay. While I'm here, if this is 55, then this is 55. This angle is 180 minus 55. That was part of our conversation from yesterday. I don't know why I just grabbed a calculator to do that. That's okay. So angle A is 125 degrees. And I might even write that down. Or it's always 180 minus the first answer your calculator gave you, right? This is an isosceles triangle, so if this is 55, then this is 55. And so to find this angle, they're supplementary, we'll do 180 minus. Okay, great. So at this point, I'm going to finish triangle number 1. Remember that all 3 angles have to add up to 180 degrees, so that's where I'm going to start. I'm going to start by doing 180 minus 55 minus 38. That means angle C is 87. And you know what? I lied. Let's go ahead and just do the same thing over here. Those 3 have to add up to 180. So 180 minus 125 minus 38 leaves us with a little 17-degree angle in there. Okay. Now, we just need to find side C. So I'm going to use the law of sines again. Remember, we started off with this angle and its opposite side. So I have the sine of 38 over 45 equals the sine of 87 over little c. And so I'm going to cross multiply. And then I'm going to divide. The math here today is not new. We've been doing this, finding missing things in triangles. What we're really talking about today is organization and making sure that we're finding everything we need to and considering every case. I'm sorry, I'm typing this into my calculator. And so I get C equals, let's call that 73.0 if we're rounding to the nearest tenth. Okay. And I say if, there was nothing written down. That's what we did on the last one. Okay, so we finished triangle number 1. Let's finish triangle number 2. It's going to be the same thing that we just did, right? I'm going to start with that given pair. The sine of 38 over 45 equals, and now we'll do the sine of 17 over lowercase c. But the math is all the same. C times the sine of 38 equals 45 times the sine of 17. And then we'll divide by the sine of 38. We'll grab our calculator. So much repetition. And I get 21.4. So side C changed drastically, but I don't think that should surprise us. In triangle number 1, angle C was the biggest angle, so it's the biggest side. In triangle 2, it's the smallest angle, so it should be the smallest side. Remember what happens to side C. This is side C, right? It was 73, but when I swing that gate in, it gets much shorter. Right, and I say much shorter. It doesn't look like it in here, but this picture's not drawn really to scale very well, and that's okay. So the math that we did in here is not anything new. What we're paying attention to is how many triangles are possible, and if there's 2, staying organized and making sure you're really paying attention to lining things up and using the right angle side pair.